Sugar is not just a harmless pleasure or a simple source of energy. It is one of the most underestimated substances shaping modern human health. The real danger of sugar does not come from the spoon you add to coffee, but from the vast amount hidden in everyday food. For most people, sugar is invisible, normalized, and socially accepted, yet its impact on the brain closely resembles that of addictive drugs. Scientific studies show that sugar activates the brain's reward system by releasing dopamine, the same neurotransmitter involved in addiction. Over time, the brain adapts to this stimulation and demands higher doses to achieve the same sense of pleasure. This mechanism creates a cycle of craving that operates quietly, without dramatic withdrawal scenes, but with powerful behavioral consequences. What makes sugar especially dangerous is its omnipresence. It appears not only in sweets and soft drinks, but also in products commonly perceived as healthy. Yogurts labeled as light organic snacks, breakfast cereals, sauces, and even processed meats often contain large amounts of added sugar. This means that many people consume excessive sugar without ever making a conscious decision to do so. The modern food environment is designed to keep blood sugar high and cravings active. As a result, the average person consumes far more sugar than previous generations, even while believing they are eating responsibly. This hidden exposure turns sugar into a silent driver of metabolic and neurological stress. The first step to understanding the sugar problem is realizing that this is not about weak willpower. It is about biology interacting with an environment engineered to exploit it. Sugar does not announce itself as a threat. It integrates into daily routines and gradually reshapes appetite, taste, and behavior. By the time its effects become visible, the habit is already deeply ingrained. The addictive power of sugar becomes fully visible only when we examine what it does inside the brain. Sugar is not processed like a neutral nutrient. When it enters the bloodstream, it rapidly influences the brain's reward system by triggering the release of dopamine, a neurotransmitter responsible for pleasure, motivation, and reinforcement. This is the same biochemical pathway activated by addictive substances such as nicotine, alcohol, and cocaine. From a neurological perspective, the brain does not clearly distinguish between sugar and drugs. It simply registers reward and learns to repeat the behavior that caused it. Animal studies confirm this mechanism in disturbing detail. In controlled experiments, rats given intermittent access to sugar show stronger signs of dependence than rats exposed to cocaine. When sugar is suddenly removed, the animals display anxiety, irritability, trembling, and difficulty concentrating. These are classic withdrawal symptoms. Over time, the brain adapts to constant dopamine stimulation. What once produced pleasure becomes normal, and normal becomes insufficient. Larger quantities of sugar are required to achieve the same emotional response. This escalation happens quietly and gradually, which is why people often feel their cravings intensify instead of disappearing. Sugar also disrupts the balance of other neurotransmitters, including GABA, which normally helps inhibit impulsive behavior. When this system is weakened, self-control declines and eating becomes automatic rather than deliberate. Another crucial effect occurs at the level of taste perception. Frequent exposure to high sugar levels dulls taste receptors, making natural foods such as vegetables, grains, and unsweetened dairy feel bland or unsatisfying. This pushes the brain to seek stronger stimulation, reinforcing the cycle of consumption. Importantly, this process does not rely on conscious choice or weak willpower. It operates below awareness, driven by neurochemical learning rather than rational decision-making. This is why simple advice like just eat less sugar rarely works. By the time someone attempts to reduce intake, their brain has already been conditioned to associate sugar with comfort, reward, and emotional relief. Understanding this mechanism changes how we should talk about sugar. Excessive consumption is not a personal failure. It is the predictable outcome of repeated stimulation in a biological system designed to seek pleasure and avoid discomfort. Once sugar becomes part of daily life, escaping its grip requires more than motivation. It requires awareness of how deeply it reshapes the brain itself. The most dangerous aspect of sugar is not how sweet it tastes, but how effectively it hides. Unlike substances that are clearly labeled as unhealthy, sugar has been normalized and quietly embedded into everyday food. Modern consumers are not surrounded by sugar bowls. They are surrounded by products engineered to deliver sugar without triggering suspicion. Studies show that nearly 3/4 of supermarket items contain added sugar, including foods that have no logical reason to be sweet. Processed meats, sauces, ready meals, bread, and so-called lighter fitness products often contain significant amounts of sugar. Yogurts marketed as healthy alternatives can contain more sugar per serving than soft drinks. Even organic or natural labels provide no protection. Organic sugar is still sugar, and the body processes it in exactly the same way. This creates a false sense of security. People believe they are making responsible choices while unknowingly maintaining constant sugar intake. The food industry relies on this confusion. Sugar improves taste, extends shelf life, and increases repeat purchases. From a commercial perspective, it is one of the most efficient tools available. From a biological perspective, it keeps consumers trapped in cycles of craving and reward. This environment changes eating behavior at a population level. People snack more frequently, eat larger portions, and experience unstable energy throughout the day. Blood sugar spikes are followed by crashes that trigger hunger and irritability, which then lead to further consumption. Over time, this pattern becomes routine. It no longer feels like overeating. It feels normal. Statistics reveal how severe this shift has become. In many countries, including Poland, average sugar consumption exceeds 50 kilograms per person per year. This is not because people buy more table sugar, but because sugar has been fragmented and redistributed across thousands of products. It appears under dozens of names, making it difficult to recognize on ingredient lists. Glucose syrup, fructose maltodextrin sucrose, and corn syrup all serve the same function. This fragmentation hides the total dose. The result is a constant metabolic load that the body was never designed to handle. Understanding hidden sugar requires abandoning the idea that the problem is individual choice alone. It is structural. It is built into the food system itself. Until consumers recognize how deeply sugar has been woven into everyday products, reduction efforts will remain difficult and incomplete. The long-term health consequences of excessive sugar consumption extend far beyond weight gain, and many of them develop silently over years. One of the most direct outcomes is insulin resistance, a condition in which cells stop responding properly to insulin and blood glucose remains chronically elevated. This process is a key pathway leading to type 2 diabetes. Research shows that people who consume sweetened beverages daily significantly increase their risk of developing this disease, even if they are not overweight. Sugar places constant stress on the pancreas, forcing it to produce more insulin until it can no longer keep up. At the same time, excess sugar promotes fat storage, particularly visceral fat around internal organs, which further disrupts hormonal balance and inflammation. Cardiovascular health is also affected. High sugar intake is linked to increased blood pressure, elevated triglycerides, and chronic inflammation of blood vessels. These factors contribute to heart disease, which remains the leading cause of death worldwide. Sugar also plays a role in non-alcoholic fatty liver disease, especially when consumed as fructose. The liver is forced to metabolize large amounts of fructose, converting it into fat and gradually impairing liver function. Beyond metabolic damage, sugar has measurable effects on the brain. Studies associate high sugar diets with impaired memory, reduced concentration, and altered learning ability. In children, these effects can manifest as hyperactivity and difficulty focusing. In adults, they appear as mental fatigue and unstable energy levels. Sugar also affects gene expression, altering the activity of hundreds of genes involved in inflammation, metabolism, and neural signaling. This means its impact reaches deep into cellular regulation. Dental health provides one of the most visible examples. Sugar feeds oral bacteria that produce acids, leading to tooth decay and gum disease. However, even this familiar effect is part of a larger pattern. Sugar interferes with mineral absorption, including calcium and magnesium, weakening bone health and immune function over time. What makes these outcomes particularly dangerous is that they develop gradually. There is rarely a clear moment when damage becomes obvious. Instead, symptoms accumulate quietly until they are difficult to reverse. This is why sugar-related disease is often described as a slow epidemic, rather than an acute crisis. Understanding these effects shifts the focus away from aesthetics and toward long-term resilience. Sugar does not simply change how the body looks, it changes how it functions, ages, and adapts. Recognizing this helps explain why reducing sugar intake can lead to improvements across many systems, from energy and mood to metabolic stability and cognitive clarity. The most important truth about sugar is that its damage is not permanent, but its influence is persistent. This distinction matters because it explains both why sugar is so dangerous and why change is still possible. Studies show that many of the neurological and metabolic changes caused by excessive sugar intake can be partially reversed. When sugar consumption is reduced, dopamine signaling begins to normalize, Insulin sensitivity improves, and taste perception slowly recovers. Foods that once felt bland regain flavor. Hunger signals stabilize. Energy becomes more predictable. This process does not happen overnight, but it does happen reliably. Research from universities and in the United States demonstrates that even a few weeks of reduced sugar intake can improve cognitive performance and emotional regulation. The brain is plastic. It adapts to the environment it is exposed to. Remove constant sugar stimulation and the system recalibrates. Physical activity accelerates this recovery. Exercise increases insulin sensitivity, supports neurotransmitter balance, and helps clear excess glucose from the bloodstream. Studies from European medical centers show that regular movement can significantly reduce the negative effects of sugar, even without drastic dietary changes. This does not mean sugar must be eliminated entirely. It means it must stop being constant. The problem is not occasional sweetness. The problem is chronic exposure. Awareness is the turning point. Once people understand where sugar hides and how it affects the body, unconscious consumption becomes harder to maintain. Reading labels becomes meaningful. Taste preferences shift. Control returns gradually, not through restriction, but through understanding. This reframes the entire issue. Sugar is not an enemy to fight, but a stimulus to manage. Health improves not because of punishment, but because systems are allowed to return to balance. The final message is not fear, but agency. The modern food environment is aggressive, but the human body is resilient. When sugar stops dominating daily intake, the body responds with clarity, stability, and recovery. The hidden epidemic loses power the moment it is made visible.